Hey everyone, welcome back to another episode of the Barnabas Rover. You can see right here, my rover has two IR sensors. In our previous episode, what we did is we added just one of these IR sensors and we programmed it, our rover, to move forward whenever it sees the white part of the table. And then as it moves forward, whenever it detects the black tape, it would go ahead and stop. And you can see that it's kind of working, and kind of not working. And so we talked about how we need to adjust the sensitivity so it works well. Just as a recap, you see this second light here. The second light here tells you whenever it's sensing white, and then when it turns off, it senses black. So see at this point, see that second light right here turned off. It means it senses black, senses white. Okay, let me just make sure that it's working properly. This is my first sensor, so I'm gonna turn the sensitivity all the way down. So when I turn it counterclockwise, it turns the sensitivity always down. So now it's just always off. It thinks everything's black. Okay, and then so the next thing I want to do is I want to go to the white area and then turn it up just a little bit at a time until it can sense white. A little bit there. So now it can sense white because it turned on the light. And now let's make sure when we go on the black part that it can sense the black by turning off. So I'm going forward and it turns off perfectly. Then I go back, senses white again, forward, senses black. And then now I go past that forward. It's sensing the white, and once I get to the black, almost there, then it turns off. Okay, that's working properly. Now the second one, this one here on the right, same thing. I've gone ahead and wired it up. If you want to refresh on how to wire the IR sensor, you can look at the previous video. But it's the same process. The only difference is that the out signal I connected to pin number 12. Okay, pin number 12, and that's going to come into play when we start programming the second sensor. But before we do that, program the second sensor, we want to make sure that it works correctly. So right now I have the two lights, and notice that these sensor lights are red and these are green. You might have both green or both red, or one of each. It doesn't really matter. So I just want to let you know, if your colors are different color, like green or red, it doesn't matter. Okay. The idea is just as long as you have two LEDs, okay, on your sensor. So right now it looks like it's working properly. So I'm just gonna go ahead and leave that, because when it's on the white, it's both are on, and then when we get to the black, you see one of the LEDs turns off. Okay, great. Now, one thing I would do, because these IR sensors are kind of sensitive, right? And you can notice that if I go past it slightly, then it becomes white, and then they both turn on. And I have to kind of be just right. I'm looking at this green one right here. You gotta be on it just right for the light to turn off that sensing LED. So I think one good idea is to actually make my track here a little bit thicker, and I actually recommend that. So if you have regular tape like this, like, go ahead and make a little bit of a wider track, so that way our rover is going to have more opportunity to sense the black. Okay, and that's just going to make our lives easier when we start coding it. All right, so I'm going to go ahead and pause this and go ahead and do that. Okay, so I've finished my track here, and I'll go to the top view here. You can see that my track is thick all the way around, and that's definitely going to help us when we do coding. Okay, now the other thing I want to mention is the sensor placement. All right, so I was playing with this earlier, and I found that if these two sensors are really close, like let's say the sensors here, and then this one we moved it here so that it's only like, you can't quite see, but see my two fingers here. Let's say the sensors are only this far apart, like they're right squished up against the sensor. That doesn't work very well. The reason why is that we're going to get our robot to try to like wiggle and go back and forth along the tape. So if my two sensors are the same width as the tape or close to it, what happens is that whenever the robot turns, let me change the view so you can see better. To the top-down view here, right? So our robot's going to try to wiggle in between with the black line in between. But if the two sensors are really close, what happens is if it tries to wiggle one way, it'll just overshoot and go totally off the path, and that's not what we want. It's going to get really confused. And so the way to fix that is to make sure that the two sensors are further apart. Okay, so you might ask, well, how far apart? Well, mine right here, my sensors are about 4 inches apart. Okay, so I would say let's make sure your two sensors are at least 4 inches apart. Okay, great. Okay, so now that we're good with that, let's talk about how we're going to code this thing. Okay, so looking at the top right there, we can see that we got two sensors, right? We have the right sensor right here, and then we have the left sensor right here. And what we're going to do is come up with an algorithm. An algorithm is basically the way our robot's going to make decisions. Okay, so we have the right sensor. Okay, whenever the right sensor sees black, what do we want to do? We want to turn this way. And then whenever the left sensor sees black, what do we want to do? We want to turn that way. All right. And so let's go ahead and write that down. So I'm going to use my whiteboard here. So number 1 is when left sensor sees black. Okay, what do we want to do? So the left sensor is this one right here. When the left sensor sees black, we want to turn left, right? When the left sensor sees black, we want to turn left. And we want to do a tank turn. A tank turn is when we turn the left wheel and the right wheel at the same time. So it's going to be like this, okay? Like this. So the left wheel goes backwards, the right wheel goes forward. All right? So we're going to say tank left. Number 2, when the right sensor sees black, what does our robot want to do? When the right sensor sees black, we want it to tank right. Tank right. And then there's this third situation is when both sensors see white, just go straight because everything's good. So the third situation is both sensors see white, go straight. I'm going to go and also think about this. What if both sensors see black? See black. What do we want it to do? So both sensors see black, it means that it's kind of like this. That means something's messed up, right? Because we want it to be either it sees all white, or one is white and one is black, right? If they both see black, something has gone wrong, and so we just want to stop. Let's say that. And I'm kind of doing this as like kind of a trick too. The reason why is that when it sees black, it's saying that it doesn't sense any IR coming back. So what that also means, I'm gonna change my view here. Okay, I'm on a table right now. Okay, and what that means is that if my car tries to drive off the cliff, what happens is the two sensors, these two sensors here, are actually gonna sense nothing because it's just air down there, and that's the same thing as sensing black, because there's no IR being shot back into the IR sensor. And so what that does is it prevents my robot from flying off the table. So that's a nice little trick I have too. Another thing that it does is that both sensors sense black. Also, if I lift my rover all the way up in the air and it's not getting any IR because it's traveling such a far distance and nothing's getting shot back into the receiver, that it's also gonna just stop. Okay, so if I lift my robot really high, it's also gonna stop. And so that's a nice little feature that I have there as well. If I have this number 4 thing, when both sensors see black, just stop. Okay, and to clarify, I'll also say I'll write this: if both sensors see black or nothing. Because kind of when the sensor sees black, when the sensor sees nothing, it's the same situation here. All right, let's do some coding. Okay, here we go. I have my algorithm here. Okay, I have my code here. And let's get to work. Okay, so the first thing I want to do is I want to set up my sensor pins. So I have my first sensor, and that one was this one right here, which is my right sensor. All right, that was pin 6. I did that last time. So I'm not going to call it IR sensor pin anymore. I'm going to call it right sensor pin. That's easier to remember. And then I'm going to say left sensor pin for my new one, this one over here. You can see my camera. Okay, and that I chose number 12. Again, if you need help on how to wire that second sensor, I recommend looking at the previous video. Okay, because I show you how to wire up this sensor, the right sensor. So you just do the same thing, except for this one, do pin 6 for the out pin do pin 12 for the out pin rather than pin 6. Okay, so left sensor, we wire that up, and we're going to do number 12. The next thing, we got to do our pin modes. Okay, so line 42 here, I got to do them for both of them. So it's no longer I sensor pin, it's right sensor pin and left sensor pin. Okay, great. So I have all that set up now, my pin modes. And let's go down to my loop. Okay, so I have 4 situations. If you look on my right here, I have my algorithm, right? 4 situations. And let's go ahead and type in some comments here, get our code going. All right, so we have to say if something, do something, right? So let's see situation number 1. If, so this is left sensor sees black, then I want it tank left. Great. So that's my situation 1. Situation 2 is if right sensor sees black, tank right. Okay. And again, I'll type in the rest of the code later. These are just putting some comments and some placeholders. If my comment says both sensors see white, go straight. Okay. And then last one, if both sensors see black or nothing, stop. Okay. So we have our basic structure here. We just need to fill in the blanks here. All right, let's fix this. It should say left sensor. Okay. Okay. So I'm going to have to test and see what's going on with my sensors quite a bit. So I could say right here, left sensor sees black, right? So I could say digital read, what was it? Left sensor pin? I'm going to check it out. Yeah, left sensor pin. I'm going to copy this. Left sensor pin, and if I remember correctly, it should be 1 whenever it sees black, so equal 1, right? So I could do that and then kind of go through all the situations here, but to make it cleaner, what I can do is I can create variables. Okay, so I'm going to say int left status equals what I have here. Okay. And I'm going to say, instead of all that, just say left status equals 1. Okay, it's just cleaner, okay? And since I want left status, which is the status of the left sensor, I also want right status. Int right status equals digital read right sensor pin. Okay, looking good. And so now I can say down here on this line, if right status equal 1, and then this one's here, if both sensors see white. If both sensors see white, that's left status equal 0 and right status equal 0. Because remember, 0 is white and 1 is black. So if both of them see 0, then we're going to go straight. We'll fill that in a second, the stuff here. And then if both see black, that's left status equal 1 and right status equal 1. Okay? So you can see what's nice is because we have these variables here, we don't have to type this stuff all inside here and here and here and here, because then it gets really messy. Okay, so that's why we have these variables up top. And what's also nice is that each time, because all of this stuff right here is in a loop, each time we get to the beginning of the loop, it updates left status and right status, right? So before we start doing this if stuff, before we start doing all this code, every time before we start doing that, we update left status by checking digital read left, and also right status by checking digital read right. So everything should work okay. Okay, great. So we have our logic there. Now we just have to do tank left, tank right, go straight, and stop. So stop, we already have that. No problem. We've written that a long time ago, and that works. Now what about, let's go with this, go straight. Go straight, we should have some code. So let's go here. And I'm gonna just simplify our code a little bit, because here we have like a move forward no distance with speed and all that. I'm just gonna make a void forward. Okay, and void forward's gonna just move motor A and motor B forward, and I'm just gonna try a speed 150. Okay, at this point I don't worry too much about if I'm going straight or not, because I have the sensors here. Before we wanted to two different speeds to make sure it goes forward, but because the sensor is actually going to look for the black line, it's going to help us stay forward. So I'm just not going to worry about fine-tuning the speeds for the motors to make it go straight. I'm just going to use 150 and 150. Okay, so then now go down here, and I'll just say forward. Okay, so it looks really clean here, really easy. Now what about tank right and tank left? Well, let's do, since we're going this way from the bottom up, let's do tank right. So let's go to forward. I'm going to copy this, and let's do tank right. So for tank right, what's going to happen is that the right motor, which is this one, needs to move backwards, right? And then the left motor needs to move straight. All right. So let's get everything correct here. So left motor is this one, which is motor A for me, I believe. So motor A goes straight. So I'm going to leave this the same, and then motor B goes backwards. So motor A goes forward, motor B goes backwards. So motor A I'm going to just leave the same, motor B I'm going to flip. Okay, that should be tank right, and I'm not super sure, so I just want to actually just test it out. Oh, let me fix this really quick. Left. Okay, I'm just gonna comment out this stuff right here for now, because I don't want it to do anything other than tank right. Okay, I'm just gonna test my code to make sure my tank right is working correctly. Okay, I'm gonna upload. Yep, that's a tank right move. Great. It's always good just to make sure. So tank right, that works. So then I'm going to copy this and just make a tank left, which is just the flip of it. Just flip everything. Cool. And then let's just test my tank left. What did I do here? Oh, forgot. And that is a tank left move. Sweet. Okay. So now I confirmed I have tank right and tank left working. I'm just gonna uncomment my stuff and just put it in. So my tank right goes here. My tank left goes here. Okay. And let's see if this thing works, all right? It's actually working pretty well, guys. Check it out. It's working. So it's following the line here. And let's see if it can go the other way. It is working pretty well, actually. All right. Okay, well, let's add a few more things here while we're at it, right? First thing is, I don't know if you can actually hear it, but what's going on here? I don't know if you can hear it, but when I'm up on the table here, it seems that like the motors are they're like humming, but right at, earlier we had code, which is number 4, right? Number 4. Let me change the camera view because you can't tell. When I'm up in the air like this, the motor should just be stopped. And the motors are stopped, but I can hear like some humming. So I think what's actually happening is that the motor is trying to start and then stop, but really fast. So you can't really tell that it's trying to move. So it's like start, stop, start, stop, start, stop. Okay, so looking at the code, I see the problem. So we have situation 4 right here. It says that if both sensors see black or see nothing, it should stop. So this is correct. But what we have is also, if you look up here, the code processes line by line, right? So before it even gets down here, it's going to go up, first look at this and say, well, does the left sensor see black? Well, if both of them see black, the left sensor definitely does see black, so it's going to try to tank left. And then when it'll go to this, well, does the right sensor see black? Well, that one says black too, so then it'll try to turn tank right. And then it'll skip over this one and then go here, and then finally, since it says both are seeing black or nothing, it'll stop. So what the code's doing when we have our robot up in the air, it's going to tank left, tank right, stop. Tank left, tank right, stop. So that's why we see here that buzzing. And so in order to fix that, we want to be more specific, right? We want to make it so that whenever it's up in the air, it only does stop. So what I mean is this. All right, so situation 1 is when the left sensor, this one right here, sees black. Well, how can we be more specific? Well, whenever we're in this situation, the left sees black, well, what does the right see? The right sees white. So let's add that in. So going on to line 268 here, we're going to say the left status is black and the right status is white. All right. And then same situation here. Down here, if the right is on the black, then the left is on the white. Okay, there we go. And so now we have, it's asking about the status of both sensors in every single situation. So then now our code should work correctly. All right, so let's go ahead and upload this. All right, I'm going to change my view here. All right, I'll move this down here. And so yeah, now when I'm up in the air, Change again. Up in the air, no motion. Down low, going. Up in the air, no motion. And then let's make sure that line following still works. Still working. All right. And use the battery. Make sure it works with the battery. All right. Awesome. And then with my extra feature here, I lift it up, nothing happens, and then I can also try driving. Well, stop there because both sensors are on the black tape. See? That's why it stopped there. Now I can push it so that it keeps going to the edge of the table, and it should stop because I put in this little safety feature. I'm pushing it. Oh, it actually turned this way and stopped. I'm gonna push them both. So it's trying to go. There you go. Kind of scary, but it definitely stopped. Okay, so this is kind of dangerous there, but if you coded everything correctly, your robot should be protected from flying off the table. All right, let's do this. Oh, this will be interesting, right? My black tape ends here, so it will probably just keep going, but hopefully stop here, which is also the edge of the table. There we go. Awesome. Okay, so there we go. So we have a robot that does line following. Pretty cool. Okay, what you can do is create a path, kind of like make it do a lap, and if you get it done correctly, it'll just keep going in a circle around. If you just do a whole entire closed loop with the tape, you can make it go around the classroom, go around your house maybe. Another thing you can do is add extra button functionality. We've played with the button, right? So you could press the button and it starts following the line. You could press the button again and it starts detecting objects using the sensor, the ultrasonic sensor. You press it again and it does light following. Maybe you press the button again and it does something else. Okay, so there's a lot that you can do with what we have here. But for now, I'm super happy, super psyched that we get the line following working. And so I'm going to stop there for now. All right, enjoy, have fun with that, and let me know how it goes.